All right, so number 24 is where we're going to start. And what you're going to notice that's a little bit different about these couple pages, which is actually to your advantage, is that if you look at the right-hand side, your answers are given. So it's kind of like you're given the problem, you're given the solution, you just have to figure out what goes on in the middle, all right? You're in Quincy, you want to get to Disney World, but you got to figure out the path in which to get there. All right, let's make it a fun place that we're going to go. All right, and I think you're going to find a little bit of satisfaction out of having this here, because it's like when you get to that last piece and you're like, oh my gosh, I can see it. There's something about that that kind of, well, at least for me, just pretend like you kind of get a little, I know Brad will, get a little excited about it, that, oh my gosh, I'm on the right track, here we go. All righty? Okay, so we're going to start with number 24 and hit on that. So first we start out with 1 plus tangent x over 1 plus cotangent x. Be very careful. When we were looking at our identities, and we were looking at the Pythagorean identities, I said the number one mistake is you're going to want to take a Pythagorean and break it down to a single trig. Instead of a tangent squared, you're going to want to take it down to a regular tangent, because this is not tangent squared and that is not cotangent squared. We do not have a Pythagorean identity here. Well, gosh darn it, that just kind of takes the wind out of my sails, and I've got to figure out a different route to go. But that's when you're like, aha, I remember when Mrs. Meyer said that if we get stuck, we need to at least take one step, at least go in one right direction. And she said to always try to write it in terms of sine and cosine. Now hear me on this, and hear me well. Even if it looks awfully ugly, like there is no way that if I write this that I could ever solve it, try it, okay? You might like it, okay? Just be like Mikey. Do you guys know what that means? Yeah. Okay, we'll explain that when we're off video. Okay, so here we go. So can I rewrite tangent in terms of sine and cosine? Absolutely. That's what we're going to do. You're going to want to write fairly small, I mean not super small, but you know, we will be taking up this space in here, okay? So we're going to say 1 plus tangent is sine x over cosine x over 1 plus cotangent is just the reciprocal of that, cosine x over sine x. And we're going to be saying a lot of sine x's today, and I'm just going to put it out there that every time I say sine x, I think it's like some allergy medicine. So we might refer to sine x as, you know, our allergy med or something. So we've got 1 plus sine x over cosine x all over 1 plus cosine x over sine x.
Couldn't you just, instead of going from tangent to sine over cosine, just go from tangent to 1 over cotangent and then like cancel or something?
That's a good point. If they were being multiplied, absolutely. But because they're both terms, they don't cancel. But that's a good point. Okay, so we got sine x over cosine x over sine x. I've got two fractions. Well, no, not really. I've got two terms, one of them a fraction, that are being added. What do I need to do if they're needing to be added? If I've got two fractions, and I'm just going to say a fraction here, I need to have kind of like a like term, but what's it called? A common denominator. A common denominator. So only looking at the numerator, what would be the common denominator up here be? What's the only denominator I see? Cosine x, so that's going to be my common denominator. So what I'm going to do is I'm going to rewrite the number 1 with the denominator of cosine x. And if I want to not change the value, but keep the value the same as number 1, what has to go on this numerator? Is 1 over cosine x the same thing as 1? Cosine x over cosine x, anything divided by itself is always 1. And so that's why that's the equivalent to 1. And now I have a common denominator. They both have the same denominator. I just converted the number 1 into that same denominator. I'm going to do the exact same thing to the denominator. But this time, the denominator in the denominator is sine x. So what's the fraction going to be in place of 1?
Sine over sine.
Sine over sine. So allergy medicine over allergy medicine plus cosine x over sine x. Okay, everybody with me so far? So now I'm just going to take that numerator and rewrite it over the common denominator, just to simplify it, that's all. And just so that you know, we are going to be utilizing a lot of finding common denominators and fractions. And so making sure that you understand that process before we move on is important. Okay, now knowing that we have the answer out here is tangent x. And I've got, what I have here is I've got a fraction being divided by a fraction. I multiply by, and again, this is a step that you're going to see over and over and over again, to where you're going to multiply by the reciprocal. And when I say that, I had a question first hour. The numerator always stays exactly as the same. You don't touch the numerator. So I'm going to come down over here. So I have cosine x plus sine x all over cosine x. And my division problem now is turned into a multiplication problem. And this is just going back to basic math. When we were learning how to divide fractions, 1/2 divided by 2/3, we changed that division problem into a multiplication problem. Same thing here. Okay.
With your numerator, like fraction, can you just cross out the 2 cosines and then...
Right here?
Yeah.
Great question. Why can I not do that? Because of this plus right here. It's 2 terms. If these were being multiplied, by all means, go for it. But because that's an addition, all those rules kind of go out the window. If it's terms, you can't cancel. If they're factors, you can. So I get sine x over sine x plus cosine x. Now what I'm going to do is I'm going to put, because of what Gabe was mentioning, I'm going to put parentheses around my addition, around the terms, so that you know that that is one quantity. It can't be separated out. Okay, so just take a second and just kind of look at what I have. And look at where I'm going. What can I do?
You can like cross out the cosine plus the sine.
Are those identical?
Yes.
They are. That is what gets to cancel. So cancel, cancel. What am I left with?
Sine over cosine, which is tangent.
You got it. Isn't that satisfying? Anybody?
Yeah, I thought you knew what I was saying.
Thank you. And then you get to tangent. Look at that. Just like that. Okay, questions before we move on? Okay, straight down, 27. This time we want to end up with secant. Okay, this time we want to end up with secant. And I had said that anything that you can do with a variable, you can also do with a trig function. So if you want, look at this as sine x times the quantity tangent x plus cotangent x, or a times b plus c, if you want to look at it like that. What do I want to do? I want to multiply it out. I want to distribute. Well, first of all, let me back up. We want to rewrite in terms of sine and cosine, but because of the way this is written in terms of 2 parentheses like this, that's really not going to help me at the get-go, but we'll get there, okay? In fact, how the order in which you do that really doesn't matter. And if you're like, what is she talking about? Just stay with me here. Okay, so this becomes, I'm going to take sine x, and I'm going to multiply that by tangent x, plus sine x times cotangent x. I just distributed. Like if it was variables, it'd be a times b plus a times c. And that's all I did. That's all I did. Yesterday, we were pulling out the common factor to get to what we originally had here. Today, we're doing the reverse. We're multiplying it back out again. All right, so sine x tangent x plus sine x cotangent x. There's no identity. There's nothing that can help me with that. So now we go back to what Meyer said as far as when all else fails, actually not even all else fails, even always a good first step, convert into sine and cosine. All right, well, I already have sine here. But tangent is what? Sine over cosine. Cotangent is what? Cosine x over sine x. Okay, so there's my conversion. So now I'm into all sines and cosines. Life is good when we've got that. So now, even though you might not be able to see where you're headed, just go ahead and do what comes natural. So this is sine squared x over cosine. I just multiplied numerator, multiplied denominator, plus the second term. What happens with my sines? They can cancel. So I'm just left with cosine x over 1. All right? Now I'm back to those two fraction things again. What do you think I'm going to need? I need a cosine on the bottom over here. So what do I need to do to both the numerator and the denominator here? Multiply by cosine x over cosine x to create a common denominator. So the first term stays exactly as it is, sine x over cosine x plus, now I get cosine squared x over cosine x. And what I have now is a common denominator. So I'm going to write that numerator including that common denominator. That's not a star, that's actually an X. I kind of got a little pen happy there.
Wait, why did you do the cosine x over cosine x? Like, why did?
Right here,
Yeah.
common denominator. Adding fractions. This needs to have a denominator of cosine x in order to combine them into one fraction.
But that's not one. That's why I'm confused.
What's not one?
Oh wait, yes. Okay, never mind.
That is.
Okay, yeah. I see
Yep.
what you mean.
Mhm.
'Cause
This is
cosine
the
x-
new.
So cosine x just means one, in a way.
Yes, cosine over cosine is 1. And I can multiply anything by 1 and not change its value. That's why I can do that. That's why the numerator has to be the same as the denominator to keep that. Okay? I want to get to secant. What's my numerator equal? There's my Pythagorean identity that we should all recognize. Sine squared x plus cosine squared x is 1. So I get 1 over cosine x, which is secant x. Okay, anything on there that you need or want me to go back and re-explain? Finding those common denominators. Anybody? Hallie?
I just have a random question. Like on the test, do you want us like if it's asking to simplify like all the way down, does it have to go to sine, cosine, tangent, or like cosecant, secant?
Yes, it will go down to one trig function.
Okay, so you wouldn't leave it as a fraction or
No.
anything? Okay.
Like this is not completely simplified. That is. Mhm. And I think you're going to find on today's pages, having the answer out here, knowing where you're headed, can be helpful. Because then you know that you're at the end, you know? Okay, all right, flip over. Not really. Flip your paper over. And we're going to do the one that says simplify, that has no number. That's kind of obvious. That's going to be the example. And on this one, we're going to cosecant squared x. Okay? And what we have on the numerator is a binomial being multiplied by a binomial. So algebraically, it would look like x minus 1 times x plus 1. And if I have x minus 1 times x plus 1, what method do I use to expand this back out again?
Distribute.
Distribute, absolutely. Foiling, some people might have heard of foiling. Okay? All right, so we start with that. So it's going to become cosecant x times cosecant x, which is cosecant squared x. So that's what I multiplied first. Then I'm going to take cosecant times 1, which is a positive cosecant x. Now I'm going to go with the negative 1, which is on the inside. I'm going to take negative 1 times cosecant, which is a negative cosecant x. And then last, negative 1 times 1 is negative 1. All of that is still over cosine squared x. And some of you might be questioning, and that's good, is why did we not convert this first to 1 over sine minus 1 and do like what we did before? You could. You absolutely could, but you would still end up having to multiply out. And it's easier to multiply without a fraction than it is with a fraction, okay? Yeah.
Can the positive and negative cosecants cancel out?
Absolutely. Those are going to cancel. Cosecant, positive cosecant, negative cosecant cancels. So I'm left with cosecant squared x minus 1. And any time that you see a trig function that's being squared with a 1 or a minus 1, you can automatically take your eyes. More than likely, it will be a Pythagorean identity. Do I have a Pythagorean identity with cosecant x minus 1? It is cotangent squared x. And that's not a matter of figuring it out. That's just a matter of looking at your identity sheet. Okay? Now, cotangent x by itself doesn't help me anything. So now is, again, wise words spoken to you the other day. Convert to sine and cosine. So cotangent is cosine squared x over sine squared x, all divided by cosine squared x. And I'll just make it over 1 since we're dealing with fractions. I've got a fraction being divided again by a fraction, multiplied by that reciprocal. Numerator stays put. I only take the reciprocal of the denominator. That means I flip the denominator upside down. And this is where we should start getting a little excited, because we can see, oh my gosh, that's going to cancel, and I'm left with 1 over sine squared x, which leads me to my answer. Cosecant squared x. Okay? Super simple, right? Absolutely. I do know I have people in here that actually find this to be enjoyable. Okay, that might be a stretch to say it like that, but, you know, this is better than some things that we've done. I actually kind of like it myself. Okay, questions so far on those, on the simplify one? Because I'm going to do one more because I do think the bottom one might be one of the trickier ones that you will see. You're thinking, seriously? More so than what we've done? Maybe. It's an opinion. So let's look at number 32. Let's do the last one. And I just want to show you that I know that you guys don't ever think that I make a mistake and everything, you know, is always perfect and whatnot. Yeah, right. I'm just going to show you, just to show you that, you know, it's not, that I started working 32 out. And I'm like, nope, not working going that way. All right. I anticipate that happening for you guys as well on many of them. And so understanding that it's okay to, and again, at least make a step in some direction. It might be the wrong step, or it might, maybe I don't want to use the word wrong, it might take you the longer way, but at least you're trying. And so here I'm like, nope, that's going to make it more difficult. So then I went back and I listened and practiced what I preached and did it the way I should. So here we go. Secant squared x times cosecant x all over secant squared x plus cosecant squared x. All of this, none of this is in terms of sine and cosine. And no, you cannot. And here's a great mistake. A great mistake. Secant squared x, secant, those cancel, and this cancels, and I'm just left with 1 over cosecant, which is actually happens to be sine. You would get 0 credit for that. Okay? This cannot cancel, and that cannot reduce down to 1 over sine, or excuse me, 1 over cosecant and get to sine. Okay? You know, and even if that was there and you did all that, you would get 0 credit because that is mathematically incorrect. Okay? Because of the plus sign. These are terms, kind of like what we were talking about before. If you've got terms, terms can't cancel. Okay? If you're That's what we were talking about. Okay, so here we go. So the first thing I'm going to do is, and even though it looks awful, convert everything to what? Sine and cosine. So secant becomes 1 over cosine squared x. And then cosecant is 1 over sine x. On this problem, be very careful about your details on what's being squared and what is not, because that's another great place for a mistake. So my cosine is going to be squared, but my sine is not, because that's a secant squared, but a regular single cosecant. So secant squared again is 1 over cosine squared x plus 1 over sine squared x. Now, when it's multiplication and I have fractions, do I need to worry about a common denominator? Multiplication?
No.
Not at all. So the numerator just gets simplified into 1 over cosine squared x times sine x. Okay, so the numerator is sitting not too bad right now. I'm in sine and cosine. Don't need a common denominator. All is well. My denominator, on the other hand, isn't quite so lucky. I've got 2 fractions. It's an addition problem. So therefore, what do I need? A common denominator. Now, our common denominators that we've had so far have been fairly simple because it's either just been cosine or it's just been sine. But here, what is going to be my common denominator? Cosine squared x times sine squared x. If all else fails and you're not sure of the common denominator, always take your denominators and just multiply them together. It may not be the least common denominator, but by gosh, it will be a common denominator. So that's how I found that, is cosine squared x, sine squared x. So this next step, I'm actually going to show a step on getting the common denominator. If you understand this fully, you do not need to show this, okay? So 1 over cosine squared x needs to be multiplied by the missing denominator. What is missing in cosine squared x? Sine squared x. And because I'm multiplying by the denominator of sine squared x, I have to multiply the numerator by sine squared x as well. And then, same thing with the second piece of that. I've got sine squared x. The missing piece of that denominator is cosine squared x. And I've got to multiply that also by cosine squared x. So basically, you're multiplying both of those fractions by 1. Our 1 just looks a little different. It's cosine over cosine, sine over sine. But that equals 1. So that's why I mathematically can do that, because I'm not changing the value. So then my next step is going to be to simplify that by multiplying out. Numerator stays exactly as it is. 1 over cosine squared x sine x, all divided by 1 times sine squared is sine squared x over cosine squared x sine squared x plus cosine squared x all over cosine squared x sine squared x. All I did was multiply the denominator, everything that's going on in the denominator, by the new fraction that it was being multiplied by. So 1 times sine squared is sine squared. Cosine squared times sine squared is cosine squared sine squared. Plus 1 times cosine squared is cosine squared, and sine squared x times cosine squared is cosine squared x sine squared x.
If no one could visually see that, they would have no idea what you're talking about.
Say what?
If no one could see that board, they would have no idea what you're talking about.
Especially when I say the numerator of the denominator and the denominator of the numerator, that, you know, yeah. Okay, so the fraction in the numerator stays put again, and what I'm going to do now is simplify the denominator, because now I have a common denominator. So the numerator in the denominator gets to be, well, looky there, sine squared x plus cosine squared x. What's that equal? And cosine squared x, sine squared x. Just take a second after you guys write that down and just kind of see where we're at. This looks so complicated, but right now this can be so simplified.
For the numerator, the denominator of the numerator, you put cosine squared x sine. How did you get like just like
Where am I at?
the denominator of the numerator?
That's always been that.
Okay.
Secant squared is 1 over cosine squared, and cosecant is 1 over sine. That hasn't changed in any of these.
Okay.
And now I'm going to multiply by the reciprocal. And that numerator of the denominator is 1. So I get cosine squared x sine squared x all over 1. Because that equals 1. Because sine squared x plus cosine squared x is 1. So that becomes 1, cosine squared x, sine squared x. So then I just multiplied 1 times cosine squared x sine x, boom, and the denominator cosine squared x sine x times 1 is that. Because everything in this final fraction, notice the word final, we got there, is multiplication. everything and anything can cancel because there's no pluses or minuses.
Why did you say that the sine squared x plus cosine squared x canceled?
It equals 1. Pythagorean identity. And so my cosine squared x's, numerator and denominator, cancel. And if you look at sine squared x over sine x, if this was x squared divided by x, what would I have left? I'd have just x, which leaves me here with just sine x.